Okay, this is video number 59 for the playlist devoted to 3D Experience CATIA, the generative shape design application. The icon to be discussed is what is called curve from equations. And if you click on the wireframe tab of the ribbon in generative shape design, you get a pull-up menu here, which is has a curve from equation as one of the entities involved. Now, when one clicks on this curve from equations, this dialog box opens up. And for example, if you look at the X, if you right click it or you select these dots, it says there's two ways of doing this thing. One is through formulas, mathematical expression. The other one is through essentially curves. Now, in this tutorial, I will only do from mathematical expressions. But if you're interested to see how it's done from already created curves, I suggest you look at this this link. And this link is actually in a playlist of mine with this title, and it's right here. Okay. Yep. So the problem that I want to do is, just for the sake of illustration, make a helix using the formulas of helix. And remember, there is an icon in the in this pull-up menu, which is actually helix. I don't want to use helix as a built-in curve, but I want to be able to write the equation of the helix and make sure I can get it. So this helix is made out of 3 loops, and the pitch is 2, so total of 6 inches. The pitch is 2. There's 3 loops here, and the formula for this curve in space is given by that. Okay, uh, so and when t goes between 0 and 1, this will give you a single loop. Okay, if you multiply t by, let's say, 3, you're going to get 3 loops. Well, first I'm going to do it with 1 loop, and then I'm going to modify my equation so it does 3 loops 6 inches high. Now, the only thing is that when it comes to typing in, you have to be consistent. So you have to write expression that will give you, for example, if x is in inches, the right-hand side should also give you inches. So these are the things that I'm going to be typing in my expression. Now, keep in mind that when you click on Create Engineering Law, this dialog box opens up, and this is where you start typing your formulas. Okay, so let's go ahead and do that. I'm going to go here, and I have a wireframe tab, and you go to this pull-up menu, curve from equations. Now over here, I'm going to say insert law and create equation engineering laws. Okay, this is a name that's given. I'm going to create 2 parameters. One of them is a real parameter, which is going to be your t essentially, and the other one is going to be a parameter which has unit of, for example, inches or millimeter length. Okay, so let's do the length first. I'm going to call this name the name of this x. Okay, and then I'm going to change the type to real, and I'm going to create a new parameter. I'm going to call this thing t. T goes between 0 and 1. And now here, you're going to start typing what I just told you. For example, x equal to 2 inches, if it happens to be 2, times cosine of parentheses 2 times pi. For pi, you can either write 3.1415 or big P, big I, 3D Experience CATIA knows that this is 3.14, whatever, times 1 radiant times t. Now notice that if you don't put the 1 radiant, it's going to say, I don't know what to do. Okay, basically the inside of this cosine should be radians. 2 times number that does not have unit, 3.14, times 1 radian times t, that has unit of radians, and therefore you can take the cosine of it. That's pretty much it. And then, assuming that there are no syntax error, we say OK. And notice that my first law has been created. Here is called law number 1. Now you can go and change these things. You can call it X, law X, law Y, law Z, but I don't think you can do it here, but we can do that later, okay? So again, you create engineering law. This thing opens up, and once again, I'm going to create a real parameter. I'll call it T. Also goes between 0 and 1. And then a length parameter, I'm going to call it Y. Oops, remove that. Length. I'm going to call this thing Y. You can see that. And over here, I'm going to say Y equal to exactly the same thing that I had before, except that instead of cosine, you have sine. 2 inches, yeah, times the sine of 2 times big P, big I, times 1 rad times T. And if you get a syntax error, it's going to ask you to fix it, but that's fine. T, I think that'll do it. Assuming no syntax error, I say OK. Oops, something is wrong here. Let's check it out. We have 2 inches times sine of 2 times pi times, oh, this should be rad. It says tad. Yeah, it should say rad. Good. Very good. And the third one is, let me create parameters. This one I'm going to call Z, Z, and then real. New parameter, I'm going to call this thing T. Okay. Now my formula was for pitch of 2 inches. It was 2 inches times T. Okay. So let's go back here. So Z equal to 2 inches times T. Yeah. And then you say OK. Now notice I did one loop, and I'm going to say OK. Incidentally, if you want to change the name of these things, you can put the cursor there, or you don't have to, but if you want to, properties, you can call it law. I can call it law for X, X law. How about that? X law. I can call this thing Y law. I don't know why I do that, but anyway, Y law. And Z law. And then we say OK. Good. In the event that you want 3 loops, so basically you go here and you multiply this thing by 3. Yep, this one. Multiply by 3. Okay. And this one multiply by 3 to get the proper pitch height. Yep, that's it. Fairly straightforward. So we know how this thing works. Good luck.